Hi everyone, welcome to the Dear Azure Technical Event Community. Myself Chandra and Venkatesan. I'm going to be a host for next 1 hour and 30 minutes. You can follow me in my Twitter handle @ChandraNV and my blog is about-powershell.com. Welcome you all. So in this event, we are going to discuss about Azure Container Apps automation using Bicep and PowerShell. Right. So today's agenda is we're going to discuss about Azure Container Apps, features of Azure Container Apps, comparison of container services, key concepts, overview of Bicep, Pod and PS HTML module, Dapperize PowerShell application, build a microservice app, and a demo. So if you're not familiar with Pod and PS HTML, you may have a question like what is Dapperizing PowerShell application? First and foremost, you may get a question like how do we build an application using PowerShell? Can we do a microservices using PowerShell? Yes, of course we do. So that's our demo. So before getting on to that, let's go ahead and see what is container apps. Container apps enables developers to deploy containerized application without managing complex infrastructure. It's language and framework agnostics. It has inbuilt Dapper support for building resilient microservices or modern apps. Scale the apps, microservices, dynamically based on HTTP traffic or events powered by KEDA, that's Kubernetes Event-Driven Automation. In short, container apps is nothing but an abstraction layer on top of the Kubernetes. So, container apps allow you to run multiple container revisions. That means you have a container app which has been deployed, considered as a revision 1. You have any minor or a major modification and you're going to deploy it for the second time, you're going to get a revision 2. You can run multiple revisions and you can split the traffic 50% to the revision 1 and another 50% to the revision 2. And you can run containers from any of your favorite registry like Azure Container Registry or Docker Hub Registry. It supports autoscale and it has a inbuilt Dapper support. So you can build microservices with Dapper and you can enable HTTP ingress. Of course, when I'm going to create a container app, I need to define a kube environment. A kube environment requires a log analytics, so you can view your application logs over there. And you can use the Azure CLI extension or ARM templates to create the container apps. And of course, it also supports securing, managing the secrets. So you can have some connection strings, or you can have some kind of secrets which you need to hide, and you can keep it securely in the container apps. That is supported as well. So here comes the comparing the Azure container options. So the first question people get is like, what does that AKS does when Azure Container Apps is providing you some additional features? Container Apps is still in preview, wherein Azure Container Apps have no direct access to the underlying Kubernetes API. So AKS is the way to go if you need access to all the AKS API, but not the Container Apps. App Services is optimized for hosting web applications and integrates with Azure Container Apps and Azure Functions. Okay, just make sure of that. When you're going to pick the service, you have to make sure that is going to be apt for the application you're going to host. So that's what exactly this particular deck talks about. So you do have Azure Container instances, which has no concepts like scaling, load balancing, and certificates. The interaction with ACI is through other services. For example, AKS can layer orchestration and scale on ACI through the AKS virtual nodes. Alright, that's how you interact. To scale 5 container for an instance, you need to create distinct container instances, wherein that's not the case in Azure Container Apps. The last but not least is the Azure Functions, which is my favorite. The characteristics of the Azure Functions and Azure Container Apps looks 90% similar, but the way we are taking the approach to deploy our application differs. If you have a FAS model, functions as a service model, that's how your application is being built, then you can go for the Azure Functions, right? So Azure Functions programming model is a base container image, right? It makes it portable to other container based compute platforms. So you can reuse the code as environment requirement changes, right? So it's actually a debatable point. Do I need to choose Azure Functions or I want to choose container apps for the production? I would recommend go for functions because that's production ready, but container apps is not production ready. All right. key features. Container apps support for a variety of application types, including HTTP APIs, microservices, event processing, and background tasks. Flexible to write code using your language, framework, or SDK of your choice. Consider you have a team of 8 members, wherein 4 members have got good experience using Node.js, and other 4 members are good experience in Python. So you have got an SDK for building container apps. You can have a Python SDK and you can have a Node SDK. You can start building up your chunk of code, sort of microservices, and you can integrate it later in your application. So it doesn't stop you building it. And you don't need to be using one same language. You can't force developer to use same Node.js for building up the microservices, right? So if you know the language, you just go build it, and provided if it's supported in the dapper. Excellent. And its robust auto-scaling capabilities based on HTTP traffic or event triggers. It's one of the key features of container apps. It makes the configuration simple to perform a modern application lifecycle task. So you don't need to add some additional code logics, or you need to maintain the complex infrastructure as such. So those things you can avoid, and you can spend a lot more time on building your application, and you can work on your code logic a lot. Here we go with the key concepts of the Azure Container Apps. We need to focus more on environment, containers, revisions, activation state, and microservices. For me, these 5 are key concepts in Azure Container Apps. What is environment? It's a container environment that acts as a secure boundary around group of container apps. Consider I have got 3 containers. So I'm going to deploy all 3 containers in a specific kube environment. So that's a secure boundary. That's an environment that allows containers to speak each other, so that can connect each other because it's in the same kube environment. So container apps sharing the same VNet and log analytics workspace in the same environment can communicate each other. So there is no focused VNet or specific infrastructure services you need to provision, and you have to work on it to integrate it. No, you don't need to. You don't need to spend time on it. So hosting a container apps on a same kube environment, that means you can manage the related services. You can deploy different applications to the same virtual network. That means those applications can connect each other. So the applications communicate with each other using a dapper. All right. So these applications can share the same dapper configuration and also the same log analytics workspace. Consider that you don't want to allow your application to connect to the another application. In that case, you can deploy it in another kube environment. So in that case, the application A and application B, that is a container A and a container B, can't communicate because it's in 2 different kube environment. As far as I know, we can create only 2 kube environment in a subscription, but I'm not 100% sure. We can check that one. All right. Now comes the containers. Containers in Azure Container Apps can use any runtime programming language or development stack of your choice because it supports inbuilt app, right? So on top, it's a containerized app which you're going to spin up here, and you can spin it up using you would have created an application using a Node.js or a Go language or Python or Ballerina, or you can pick the language of your choice. And containers can be from any private or public container registry. But the key point here is, if in case you're using a private registry, you have to go for a different authentication model. If you're using a public container registry, it's a different authentication model. That's the only difference. And for now, it supports only the Linux-based container image. It won't support Windows-based. The auto restarts the containers in case of crashes. So consider that you're spinning up a container, and it's a dapperized application. If in case the sidecar process is not kicked in properly, you can very well go ahead and restart it in your local machine, right? So you do that. Similar way, you can also have an auto restart of the container if in case it crashes. And every time you deploy it through the Bicep or ARM template, you end up creating a new container app revision. That means the first time you deploy, you get default revision 1. And if you go ahead and redeploy it with a major modification, in that case, you're going to create a revision 2. All right. Revisions. Revisions are nothing but an immutable snapshot of your container app. Consider that you rolled out a specific container app on your container on your container apps, and when you're going for a revision, the previous will be having a snapshot, all right, and that will be maintaining its own state. It's your choice to go ahead and say which revision needs to be applicable for the environment. Say for example, you have a container with a revision 1, where you have got some cool new features, and probably that is not required for your organization, or you may want to add some more features. So you go ahead and modify the code and redeploy the container in the container apps. In that case, you get a revision 2. You can also split the traffic, as I said in the previous deck, that you can choose 50% of the traffic goes to revision A and another 50% goes to revision B, right? But also you can go ahead and make sure you can go ahead and deactivate one of the revision and give 100% traffic to the required container. It's up to us to choose it. So there is 2 type of scope changes here. One is a revision scope changes, another one is an application scope changes. So anything changes to the containers, add or update scaling rules, changes to data settings, any change that affects the template section of the configuration. These are all considered as a revision scope changes. If in case you are changing the traffic splitting rules, consider like 50-50 to traffic A, container A and container B, or 40-60 to container A and container B. If in case you're going to do that, that's going to be application scope change. And if you're turning ingress on and off, changing the secret values, anything you change outside the template section of the configuration is considered to be an application scope change. And next comes is the activation state. In active revisions, remain a snapshot record. As I said, it's going to hold that state where we last deployed the revision, right? And there is no charges are applicable for the inactive revisions. Say consider I have 10 revisions, only 1 is active and all 9 are inactive. You're not going to pay for that. But if you split traffic and you're going to use for one of the containers, so consider that you're going to use 2 containers through the split traffic, in that case you're going to pay for that. Okay, so that makes sense. And you can have up to 100 revisions remain available before it's getting purged. That's the maximum upper cap limit given by Microsoft. So here comes is the application lifecycle management. So I think whatever I've explained it theoretically, we have got a image over here that will represent the same. So we have got a deployment. Upon the deployment, the first revision is automatically created. You can stop it because that's by default. So you're going to have a container and pod and revision 1. That's the active revisions. There is no revision there. So by default, that is going to be your active revisions. That's where your application runs and it's going to serve for your organization. I have an update now. As a container app is updated, a new revision is created. So that's going to be revision 2, which you can see it over here already. So that also have same copy of what exactly I've done in revision 1. But if you have got some changes, it's going to be available only in revision 2. The changes we have done is not going to be scoped to revision 1 because that's an older image, right? Clear. Now I'm going to deactivate my revision 1 because it has got the old config, old code, or the cool new feature is not available in revision 1. It's available only in revision 2. In that case, I don't want to give that to my users, end users. So I move revision 1 to the inactive revisions block and I have an active revision block. That means 100% of HTTP traffic is going to flow to my revision 2. Excellent. Shutdown. As a container app scales in, or app is being deleted, or app is being deactivated. In that case, shutdown is the state. Microservices. So using the container apps, what we can do is you can build a resilient, stateless, stateful microservices, right? So that supports it. So that's one of the key feature of container apps because it's inbuilt dapper. So it supports the independent scaling, versioning, and upgrades of the container. So it also enables the service discovery for us. And as I said, it's a native Dapper integration. So whatever the Dapper provides, that is a feature included in your containers. That's how we need to consider it. So Dapper plays a vital role for building the microservices because it will remove a lot of the painful part of building a microservices from the scratch because it has got its own building blocks and stuff, right? So you have to take a quick look of that. Now we have to cover something about the Bicep. Bicep is nothing but a next-gen ARM template. So that provides a good user experience for IT pro like me to make an infrastructure as a code in a DevOps way. So I just have something to be created on Azure, be it a resource group, or I want to consider deploying a container app, or I create some bunch of resources. I can do it through Bicep without writing JSON from the scratch, or I don't need to worry about like how do I do that? How do I interconnect the resources? How do I do the dependency management? So Bicep will take care of all that, helps you out to write a Terraform way code. I don't want to compare that with Terraform, but still the stylish is like that. So you can say Terraform way coding, and you can use Bicep instead of a JSON because it increases the user experience. That's the motive for Microsoft, to help IT pros to make the infrastructure as a code at ease. So you have to take a quick look on GitHub link. Again, in short, like Bicep is a domain specific language, it's a DSL based. You don't need to work a lot more like what we have done it in the JSON. So that kind of a painful task is gone, right? So since my Bicep is from Microsoft, like it support all resource types in Azure and the API versions. Whenever there is a change, you can get that on the Bicep. And it's a simple syntax. It will enhance the authoring experience, supports modularity. That means I can just module my code, and I can deliver that to other deployment or development team, those who are in need of it. Consider that I have got a complex module built. I don't want my fellow team member or another set of development team who is going to provision some resources. I can just put it across on my organization GitHub or organization Azure DevOps and say that you can pull the code from there and reuse it, and I modularize it because I follow the patterns and practices. They just we will parameterize it, and they will key in the values. They're done. They don't need to take bunch of codes and rework on it, or reinvent the wheel. Simply they can reuse the code. So modularity makes that easiness for us, and also you can keep your code neat and clean. And it has integration with Azure services, as of course that's the key feature, and you don't need to maintain the state file like how do you do for Terraform. So that's not required, and it's a no cost and open source. I recommend take a quick look on Bicep, and if you are using ARM template at your workplace, try to migrate it. And now we're gonna discuss about Dapper, which is my favorite area. And the Dapper is nothing but a distributed application runtime, and it's a portable and event-driven runtime. It allows you to build a resilient, stateful, and stateless application. What does that stateful and stateless application really mean? Consider you have an API which don't need to store some data. That's a stateless API, right? So if you want to store the data for the transactions or anything you're going to post, you're performing some CRUD operations. So in that case, I will consider that as a stateful application. All right. So the Dapper runs on cloud and edge, language agnostic, and Dapper codifies the best practices for building microservices application. What does that mean? Because as a developer, I don't want to worry about the best practices to make the microservices. I simply use Dapper. Dapper will take care of it. That's what exactly it means. So the Dapper is, as I said, is a platform agnostic, and meaning that you can run your application locally, or you can run it on your cloud, you can run it on your edge, you can run it on your Kubernetes. It can be your physical machine, it can be your virtual machine. No matter wherever the platform is that's supported, you can just go ahead and fit in the Dapper, and you can enjoy that. So you can also see it has got a building blocks like service to service invocation, state management, pub and sub, that's publish and subscribe, bindings, input and output. So you can just correlate this with the Azure Functions. As I said, the characteristics matches. All right. So the building blocks also provide you the secret management, the configurations, as I said. So it's all about like how do you define it in the YAML and play around. Okay. So the Dapper exposes its HTTP and gRPC APIs as a sidecar architecture. It can be as a container or as a process. So that not requiring the application code to include any Dapper runtime code. So when I spin up a Dapper application, it's going to kick on a process that's called a sidecar architecture that can run on your container, or it can run as an independent process. All right, so that's what exactly this deck says. So if you say like, why do I see some port with 3500 odd number? What is that v1.0, invoke, state, publish? Those are all Dapper API calls. So 3500 is a default Dapper port, wherein invoke, state, publish, and secrets are the API endpoints. So consider the first URL, localhost 3500 v1.0 invoke cart method new order. In this, cart is nothing but your application identity. Method is a standard. That means I'm going to invoke the endpoint new order. That's what exactly the first URL means. In the other URL, you can see the state. So that means I'm going to work on the state management. That's going to pull out the item 67 from the state store. State store can be your default Redis cache, it can be your Cosmos DB, it can be Azure SQL, or it can be your Azure Table Storage or Azure Blob Storage. It can be of any of your choice. So that's what exactly that means. So that means Dapper has its own API. You can play around with that to work on microservices, to build a resilient, a perfect microservice. All right. Here comes the interesting two modules which I was discussing about, Pod and the PSHTML. Using these two modules, I'm going to build an application in PowerShell. Pod will help me out to build a HTTP web server. PSHTML helps me to build a beautiful front end wherein I can write a PowerShell script, PowerShell code like HTML. PSHTML is a DSL, domain specific language, which is like you write a PowerShell way of coding and then the output will be the HTML. Simple as that. It's a wrapper, right? But it's super powerful, where you can apply all the code logic inside the PSHTML. Consider that you want to do some multiplications, mathematical operations, or you want to do some kind of API invocations inside it, pull out bunch of arrays, loop through it, massage the data, and then pull out a fancy HTML. You can do it using PSHTML at ease. All right. So the pod is going to help me out to build the HTTP server, and I can host my endpoint routes. Both are cross-platform, supported in both Windows as well as on the Linux. Lucky us, this is cross-platform, so we can use it in container apps because container apps supports only the Linux images. Excellent. For both of this, I've given the docs. Please go through it and do communicate. Please do make use of it and share it with your colleagues so that it will be useful for any one of the IT pro at your workplace. Alrighty. Here comes, this is our high level diagram of what we are going to do now in our demo. In the left pane, you can see I've got a cube environment. So this is the cube environment, the color shade on the right, and it has got client and a service. All right, I've got two applications. Both are PowerShell pod application. One is going to serve the HTTP and the other one is a consumer. So it's going to provide some data for me and the client is going to consume it. All right. So I'm going to get, and the post method, I've done it in the service. Both are Dapperized. Just for a interesting factor, I'm not going to Dapperize the client application because I'm going to use it from my local machine. All right. So the service, I'm going to host it on the container app. The client is going to be in my client machine. So what exactly this yellow arrowhead says is like, since it's in the same cube environment, you can make sure the connection between these two is at ease. So I don't want to write additional code for that can communicate each other. And the sidecar architecture, as I said, the pod application and the Dapper API is going to be on the HTTP or gRPC. That's what this arrow it means. Whatever the transaction I'm doing, say for example, I'm going to consume the service and place an order, or I send some data to my HTTP server, which is in my cube environment under the service section, right? So that data is going to be stored in Azure Table Storage. Instead of using the Redis cache default state store, I am replacing that with the Azure Table Storage. What's new I'm doing in this? Quite simple. I'm not using Node.js. I'm not using Python. I'm not a programmer. I'm a novice programmer, novice developer, and all I know is PowerShell. So just with the help of two community modules, Pod and PSHTML, I can build some kind of a small glossy application and container Dapperize it, and I can just deploy it in container apps and make use of it. That's really cool. Let's see how that works. So let's get on to the demo. Here we go. This is my code. All right. So I've got a Bicep code here, which is going to provision some resources for our demo. So I've got my subscription ID. I've got a key vault created because I have to store my Docker username and password. For that, I need a key vault. So I've stored it in the key vault, and I'm giving the key vault resource group name because I want to get that data from the existing key vault. That's why I'm using the keyword called existing here. So Bicep knows by looking into it, hey, there is a key vault here, man. Just go look for that in the subscription ID in this resource group. That's the key vault name. So that pulls out that information so I can read the secrets. That's really good, right? I really like that feature. And next comes is the storage account, because I want to put the state store in the table storage, right? So I need to put allow my Dapper to read the key and then account name and the storage name. It's pretty simple as that. So I'm going to read the storage account. Here comes is the first module, log analytics. So I am to create a log analytics, right? So if get onto the modules folder, look into the cube environment. I've got cube environment.bicep. Pretty simple and straightforward. All I need is, I need to make sure I create a, I have to create a log analytics. So all I need to make sure is I create a log analytics. I name the log analytics. I create it in a specific resource group and define the retention days of your choice and give the scoop of your choice. What I'm going to get out of this is a customer ID and a primary shared key. These two properties is required for me to create a cube. Simple as that, right? So back here to my main.bicep. Here I'm creating a cube environment. I have a name called cube environment. And I've got two parameters for this. One is customer ID, one is a shared key. So go to the cube environment. So I'm given two parameters here. So all these parameters, customer ID and the shared key, comes from the log analytics output. How I'm connecting that to is log analytics dot outputs dot customer ID and primary shared key. If you look at my log analytics, I have got the output, customer ID and primary shared key. It's really simple and easy, right? So just imagine if we want to do that using the ARM template, we have to take some additional steps for that. Yeah, right. So now you can look at this container apps. So this is the main module here. So this is what exactly going to create the container apps for us. And this requires a Docker registry password and the username, because I have to tell where my image resides. So it can pull the Docker image from there, right? And right next is my cube environment. I have to tell where my container should reside. That's to the specific cube environment, which I'm creating it on the fly. And I'm going to give the storage account key and the storage account name so that I can get authenticated to create the state store, table storage, right? So I've got a table name called iContoso. If you remember, I have the storage account created already. I'm playing with the existing storage account. So once this is done, we are cool. So I can say that this is successfully getting created, but I'm not sure we are going to deploy it now. And I'm parameterizing the image name, because you can change the image name whenever a new cool feature you are going to release. That means you can do the revisions in the container apps. Exactly, yeah. So now main.bicep is clear, so no issues in it. I've created an Azure pipeline YAML. So what I have done here is I've declared a few variables. I have to create a resource group, a new resource group in location North Europe. Please do select the location where container apps is supported. I tried using it in East US too. I am not really sure, but it didn't work as expected. Or probably container apps is not available in that region. You have to make sure container apps is available and supported in that region. And here comes is my service connection. From my DevOps, I'm getting authenticating to my Azure subscription. So that's my Dear Azure. I named it as Dear Azure. And I've got my image name. I've got a couple of images in my Docker Hub. It's public images, so you can make use of that. So this is my image name. So in the build, what I'm doing is I'm spinning up the Azure CLI task so that I can tell, hey, this is my service connection, get authenticated. I'm using the PowerShell core. And in the inline script, first thing I'm doing is building the main.bicep, right? So I'm good with that. So when I spin up that, it's going to throw me the main.json file. So I can just make use of that here. So I'm publishing this artifact to the container. Simple as that. Then I'm going to go for a deploy, and I'm using same Azure CLI, where I create a resource group and I do the deployment of the template, whatever we have generated. It's that simple. So I'm going to build and deploy it. What I'm going to build, I'm just going to generate a JSON file and then publish the artifact. I quickly go to my Azure CLI and then say, hey, please go ahead and quickly create a resource group and then do the deployment, because I'm defining the target scope as resource group here, right? So that's why I need a resource group, and then I deploy everything so that I can delete all at once. I can just delete the resource group. Alrighty. So what is there for my demo? I have not shown the source code. There we go. I have got a folder called employee. So that means I've got some basic HTML file that will just collect some information and then do some magic. That's it. It's not going to do some glossy high funda functional apps, just for a demo, right? So I need to show some information about the current logged on user and say like, hey, this is your cost to company, this is what your mobile expenditure is. Do you want to onboard some new employee, and collect the information and play with the data? That's what we are going to do now. So more or less like a Node.js, I've just scaffolded my project. Like I've got a views folder. Underneath it, I've got two PS1 file, home.ps1 and success.ps1. So I've got a Docker file and I've got an employee.ps1. So that is under the employee folder. So employee.ps1 is nothing but my web server code. Consider like that. That is my pod code. So using the pod module, I'm starting the pod server that will be creating an endpoint for me in my local host at the port 80, and the protocol is HTTP. And I'm telling to my pod server, hey, there is a view engine for me. Like if you are from a Node.js background, you can correlate that with the Express.js, or what we call it as the pug sort of a thing, right? So in pod, I tell that, hey, my pod engine is nothing but PSHTML. How does that? It knows. It will automatically pick it up. It knows there is a views folder, and underneath it, this guy is playing with PSHTML. All right. So I'm creating two route here. One is a get order, and another one is the post order, right? So instead of the order, I'll call this as an employee. So giving the employee route with the ID, I can query the employee information, and over here I can create the employee and I can store it in the state, right? Put it in the table storage. That's what exactly I mean. So how does this works? I'll just quickly show that. So first thing is I want to add a new employee. For that, I'm collecting the information: employee ID, first name, last name, email, phone number, and mobile required. So they will toggle it up whether they want mobile or they don't want mobile for a demo. And for that, I'm going to hit on the new employee route, right? So when I start the server, the first thing is I go hit here. That's my default route. I go spin up home.ps1 file. So what is that home.ps1 does? This is the PSHTML code. I've written some wrapper functions just to make sure that I show some fancy output. So before that, let me see if I have any sample. All right. Okay, let me quickly check that. I don't know whether I have some sample files in. All right, in repos. Let me quickly go ahead and open up iAutomate. No, I don't have one, so let me compile it. So repos iAutomate. Then yeah, I can go to source, employee, views, home.ps1. I copy to my clipboard and I'll show you what is the output of this. So successful execution of home.ps1 is going to give you some HTML output, which I've copied it already. I'll show it here as like home.html. Format the document. You can see this is an HTML output with tags, but wherein if you look at the the PSHTML code, you can see it's in a PowerShell way of writing, right? I've got HTML content, I've got a head content, I've got some body. I will share this code so you can just take a quick look and refer the documentation of PSHTML and port. You can easily correlate it and build some fancy applications. Okay, so how does this looks? What is the output of this? Let me reveal this in the Explorer and open up at my favorite browser. Boom. So that works. So we can see some information over here on the right top corner. I've got some mail notification. I've got some alarming notifications which says like, hey, there are some pending tasks for you. These are all just functional, okay? It's hypothetical. There is nothing, it is not a real world example, okay? It's just to show you that it has capable enough to do some fancy HTML way using PSHTML, right? So you can use any of your favorite front end styling, I don't know what they call it, as like some kind of bootstrap, Metro UI, whatever it is, right? So it's up to you. You can just make use of it. So here I've got a form. So if I fill in this form and just put a submit button, it's going to get the data and put it on the next HTML page, whatever the HTML page, and give some fancy information. But it won't work here because there is no server running on it, right? So, all right. So what happens if I put a submit button? It just go hit here. That's my employer out, right? Let me close this back here. So before running it, let's run this locally. Let me do dapper uninstall because it will remove the configuration which was existing earlier, because there's binary is not found. Okay, there's nothing is running over there. So let me do dapper init. Okay, Docker is not running. Okay, I can do Slim without a Docker so that I can kick on the sidecar as a process, but I don't want to do that because I got some trouble in my mission that didn't allow me to make use of that as expected. So we need to wait for a couple of minutes because by the time the Docker will start and it will be up and running. Okay, so Docker is still up and running. I mean, it's not yet ready. Okay, so let me quickly take a look of the Docker. What is the status of it? Okay, it's still spinning, not a problem. Now, what I have to do is just make sure that I don't have any resource groups existing, because I don't want to duplicate it, and at times I may get a conflict error. So I'm just deleting the HTML file, make sure that I have the right code version. What is the change I've done? Okay, this is a minor change, that's not a problem already. So if I go to the pipeline.yaml, I have a resource group which will just create rgp-dir-azure-uat. Okay, so I just want to make sure whether this exists. I'm not going to spin up because first thing is I need to do this testing in my local machine. For this I've created, no, there is no such resources existing. And also I've got the storage account and other stuffs created already. So that's not a problem, that I'm sure. So my Docker is up and running. No images. Okay, still it's starting. That's weird. That's okay. All right. So what we do now is I quickly go and check one more time that I don't have any major changes. Okay. So now that you see, I have done some work in my employee.ps1, right? So this has to be published to my Docker. I have got another pipeline in my project. We go to the icon so I have got a pipeline to build and publish my Docker images. So what does that mean? That means whenever I do a change in my service application or employee application, the job of this is to just go sure and publish this in the Docker Hub. I'll just open up my Docker Hub as well. hub.docker.com. Anyways, I have not done any major changes, so I don't need to worry about it because I've done only the common change. So the build and push. Okay, I did a mistake. I didn't do the edit of the pipeline. So I'm editing the pipeline. I'm using the Docker build and push API from the Azure DevOps. It's really user friendly. Don't need to worry about it. Just go select this and you can see I'm using the container registry I understood Docker. This is nothing but my service connection. I've created another service connection with my Docker credentials so that I can authenticate to my Docker Hub. So I'm pulling out this particular container repository, which can be dir-azure, and I've got build and push command, and it has got the Docker file thing. And where is the context? Build context. I'm just giving this one. So well and good. There is no issues in it. So I'm not going to do this execution because I've got that image already available here, right? So I don't want to waste the time. All right. So the latest version is 2464. I just want to confirm that is it available in my YAML. 2464. Good. So what do I do now is let me keep this change as it is. Go to my terminal. Just leave this as it is and check out your Docker. What happened to my Docker? Is it still running? Is it still running? What is the reason? All right, let's see if, I don't know, in the UI it may have some issue. Let me see if it can do the magic here. All right, it started. I think, yeah, I don't know. Docker is good. I can see it's installing the runtime version 1.5.1. And what happens is it will just spin up a couple of images in the Docker containers in my local machine, and it will allow me to Dapperize my application and access it. What does that mean is, if I'm going to create I'm going to run the application using the Dapper CLI, Dapper run, and provide the application ID. Then I'm going to give the Dapper port and say, please spin up this application. This is my entry point for my server. That's going to do the magic. That's it altogether. So we need to just wait for that. So now you can say Dapper replacement container exists and it's running. Okay, now I do Dapper uninstall to remove or to just demolish all the old configurations, whatever I have got. So it's removing the directories. It's success. So do it again, Dapper init. So it will just go ahead and initialize it and get the containers up and running for me. Hopefully I should be able to show that here. Let's see. Let this run, and it takes a couple of minutes to complete, so you have to be a bit patient. Excellent. Now you can see success. Dapper is up and running. So now if I go to the Docker, I don't know, the UI is not working, man. Okay, let's do like this. Docker images. You can see a couple of containers is up and running, right? So it has got the default Redis cache. It has got some Zipkin. I don't want to worry about it. For now, I'm an IT pro. I don't want to worry what is running inside that container at this point of time. I just follow the instructions, what I've learned. And I'm going to demo the same. For now, I'm not going to do it. Probably, if I get an opportunity to speak in the next event, I will definitely deep dive in Dapper. Now that I want to do another command execution. All right, I don't have that handy, so let me do Dapper. Dapper has a run command, and then I say this is my ID. My app ID is like port app, and I say app port. So let it be like, okay, I don't want to type it. I think I have it in my other repository. Let me go to my repos, and I've got it in my other repo where I can just open up my modules, my readme.md, sorry, open with the notepad or typo or whatever. Now what happens is I just want to copy that command because it's a bit lengthy and I don't need to type it and do some mistakes in a rush. All right, so let me copy this back over to my container. Put it over here to my console host, sorry, not a container. So here I'm using a run. I'm giving an application ID called port service, or you can just name it. And my app port is listening into 3000. But if you look at this application code, it's not. Right? Let me put that to 3000. Okay. I don't need to worry about it. I'll just run the pipeline. I have got an image already available in my Docker Hub. I'm going to pull it. That has a fixed one. There is no change in it. So I'm just for a demo in localhost, I'm changing the port. And then I'm defining the Dapper HTTP port to 3500. And where is my starting point? So it is going to be in my source employee.ps1. So let me do like this. Okay, I don't know why it's truncating. That's okay, because employee.ps1 is my entry point. So this is where I just hook up my HTTP server. Like push enter. Wait for the magic to happen now. So you can see your up and running message, both Dapper and your app logs will appear here. You can see your some clumsy data is appearing here, which says like, hey, this is your app ID and this is what your scope is. This is your instance name. That's my local host name, all those information, right? So let me see what exactly this is doing for me. So my application is listening to the port 3000 in the local host, right? So let me open up my browser and say localhost 3000. So what happens now? So that should render the HTML output for me, right? That worked. Fantastic. We are lucky. So if you look at this, like I've got some fancy information here, right? Like what's your annual pay in the box with euro icon. All these things are in PSHTML. I have written quite simple. There is no big complexity. If you look at this, I'm using some kind of icons here. All right. So if I do some changes, it's going to change it in my web page, in my web app, right? So that's simple. So I've created some wrapper function for this. So you can see here, show stat card. This is nothing but a div block with some kind of a class. For this, you can just go to Metro UI, metroui.org. You can just get the documentation help from here, like how to build a simple HTML application. In short, what I did is like I'm trying to take some work done by the community. I'm putting my block so that I can just build something useful for my team. That's it exactly I'm doing. This is for a demo. It has no functionality, or else I would have just shown some what I've done it at my workplace. All right, so this documentation is suffice for you to go ahead and look for some examples, and you can grab some information from there or get some HTML code and convert it to PSHTML. So if you look into the Pandora theme, this is exactly what I have mimicked, or else you can say I nicked it from here, right? So I've got some boxes and icons over here, right? So yeah, I've just did the same with my favorite colors and stuff. Now you can see it has some page form here, right? So what's happening here is it's just running. I don't know what's wrong with my PowerShell console host. Yeah, it's still working fine. So it's listening to the localhost 3000, and what should I see now? Some information, but I have not done some action on it, right? Let me do this. 1 2 3 4 5. That's my employee ID. That's my first name. That's my last name, and my email ID. My phone number, right? I need a phone, so I just say I need a phone or I don't need. So mobile required, yes, I need it. I just push a submit button. Now what happens is it should carry this information and display it in the next page, right? So it says like, hey, you successfully posted the new information, but bummer, I got an error message. It says like bad request, I don't know, let's see. But now what happens here is like you can see whatever the information I have posted here, it see like 1 2 3 4 5. That's my employee number, got some information. I can put this in my state store, right? By default here I don't have a state store because it's running on the Redis cache. It's not running on the table storage. That component is not defined here. All right, so first let's see what's wrong in my new employee success message. It's good. I don't see any issue in this. Right, so I've got a new employee. I'm collecting this information and I'm gonna call that in the state store, right? So this should help for me because I'm getting this body back. I'm getting this response and I'm invoking the Dapper API port application 3500 v1 state store, right? So I'm posting the information. That's what exactly it does. So I don't know. Let me give a try one more time. Let me go back here and say 1 2 3 4 5 6 domain.com 1 2 3 4, or like something like this. Submit it. Yes, it worked. I don't know, it worked. So now you can see the message we posted as success, and I've got some codes here and plotted some information. When I choose mobile is required S, I get the answer as S. This logic is pretty interesting in PHTML. Actually, we don't need to put a lot of work there. If you see here, I'm putting a condition. If web event object.data.mobile required is selected as S, so that means back here, if I do this switch on, that's when this block will execute. It will create a table and then it just say, hey, he has selected S. If I do selected as no, I don't, I get a table, but I see the information as no. Let me test that too. So let me do this, switch it off, submit, no. Cool, application is working. Close this, back to your console host, and you can see some information here. 1, 2, 3, 4, 5, 6, 7, and I've said like mobile required null because it has no S or on, right? You can customize it that too. My application is running as expected. So let me stop my server. I'll go to Dapper. I say uninstall. So that will clear the configuration from my local machine. All good. Now let's see if I remove this, will it clear it from my, no, it didn't. It didn't, only one container is moved off. That's okay. Let me remove all this. I don't want this running and taking some memory, but I don't think it will, but that's okay. I'll just remove it. Okay. So now what I need to do is, I know this application is up and running. I go to my pipeline. I have my iContoso pipeline, which is nothing but my Azure pipeline.yaml. I don't have any changes in this. So I just go click on run new. Before that, I'll make sure I don't have, okay, I deleted that RG. Well and good. Let me come back here, click on run. And this will start the pipeline. We need to sit back and relax for 5 to 6 minutes. So this will provision a resource group and then deploy log analytics with a cube environment and then create a container apps and then pull the image and create the application. Excellent. Let's wait for some more time. So let's see the status of this. This is still running. So once this container app is created, I can just quickly walk through like what do we see internally in the container apps. Before that, I just want to walk you through the Dapper configuration. We have done it in the container apps. So while provisioning the container app, you can take a quick look on this. Container apps. All right, let me put it on the full screen. So this is where exactly I'm creating the container app resource, right? I'm using the Microsoft.web container apps resource type with the API version of this. And make sure that you're selecting the container app kind. And also, when you're creating a cube environment, I forgot to mention, you have to choose the type as managed. If you don't do it, it won't work. At least it didn't work for me, so please make sure of that. Alrighty, back here to my container app.bicep. So I've got my properties in which I'm going to say this is my cube environment ID, what's my configuration is. So I have to tell this is my Docker ID, right? So how does it know? This is my secret password and this is my username. So that's what I've done it in the secret section of the configuration, and I'm giving the registry information, which has my Docker login server, docker.io. I'm giving my username and the password. From where I'm accessing this is in my key vault. I'll quickly show you that. I just want to give a recap on that. Main.bicep. So it's coming up from this particular key vault. So I have got this key vault already created, which is in KV Dapper, right? So I'll show you that key vault as well. Before that, let me quickly walk you through this. So I'm just telling, hey, there is a key vault, access it, get the user ID password, put it on over here in my configurations, right? So I'm defining the ingress as external equal to true. So I can access it from my anywhere from the HTTP network. And also I'm defining the target port as AD, transport as auto, right? So you have to see the same settings in the application once it's successful. Pipeline should be successfully deploying the container app. We have to wait for that. And next comes is the template. So I have to tell where is, yes, of course I've given the Docker hub information. I need to give the image information, right? So I'm saying that this is my image name, which is variable. And this is the name of the app. If you remember hyphen app ID, that's what exactly this does. And then I'm saying that my resources is very minimal, so you can use CPU 0.25 and memory as 0.5 gigabyte. I need a minimum replica scale set of 2 and maximum is 4. You can manipulate it again. When I'm going to have a Dapper configuration section, this is where exactly I tell, hey, you know, like I'm enabling the Dapper. When I'm creating a container app, you can disable Dapper. I can play around with container. But if I enable the Dapper, what magic it does is it will enable the access to the Dapper API. All right. So I've got the Dapper enabled. App port is 80 again. App ID is I can't also. When I say like my components, that means that is my state store. My component can be service to service invocation, or my component can be like my secret store or my configuration. For a demo, I picked up the state store. In the state store, I'm not using the Redis table, sorry, Redis cache. Instead, I'm using the Azure table storage. So I've picked up this and I'm passing up the meta information like what's my storage account name, key, table name, right? So that's what I did. Simple as that, right? So what it does is it just goes and configure the container app based out on this Bicep file. Let's see the status of my pipeline. The build is completed. That's a good news. If I go to the deploy, it's started the deployment. Let me go to the Azure portal, refresh it, because this is the RG I deleted. So I know. So they should refresh it and show me some status, right? All right. So now I can see the deployment is in progress. Oh, good. It's completed. That's really good. So now you can see the deployment is completed. And what do you see underneath the resource group? I see 3 resources. One is container app. Another one is a container app environment. And I've got the log analytics workspace. Cool. Let me open up the container app now. So dear Azure container app. It should give me a URL. Good. Do a right click. Put it on open link in new tab. So, wow, I'm happy it worked. So we can see here, this is my container app URL. My container app is in North Europe region, and this is the suffix containerapps.io. For now, we can't customize it. Let it be as it is. So I need to check whether this works. So before that, I need to tell you one more thing. I've gone to my bain.bicep. Where is my state store? That is my table storage. That is in stage employee dot. Okay, stage employee. That's the storage account. Let me go to my portal. Go to my home. Okay, let me search for that particular storage account. Okay, here is my storage account. If I go to my storage account and click on storage browser, or you can go to the tables, it's your wish. And in the left pane, I'll quickly expand the tables. So this table will have icon to show. That's the table name. So it has got one row already. Let me quickly go and delete this. Now I've got an empty table. Now back to my application. I just want to confirm that this is working. All the blocks you see here on top, it has no use. It's just a fancy. Right, so let me do 1, 2, 3, 4, 5, 6. So my first name, my last name, my email at domain.com, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, I need a mobile. I just push on submit. So this is going to post some information to the next HTML page. Fantastic, it worked. So we can see the URL here. It's not my local host. Awesome. So I've got some information back, right? Wow. Let me go back to my storage account, refresh my table storage. There we go with the state store. So I'm getting the information here, like my row key is 1, 2, 3, 4, 5, 6. Now what we do is just go get this URL and do like result equals invoke rest method URI, and here you can say employee. I'll show you what I'm trying to do here. In my employee.ps1, I have got another route defined called get employee, and I have to give the employee ID. Correct? So I'm going to give the employee ID now. I'm sorry, I forgot the employee ID, whatever I've given. Just go back here. 1, 2, 3, 4, 5, 6. That's my row key 2. So let me give employee / 1, 2, 3, 4, 5, 6. Push enter. If this works, we are good. Let me do result. See the information here. That's cool, right? I really enjoyed it. So now let's do it one more time. Let me go back. So now I do 6, 5, 4, 3, 2, 1. Just make it as custom shake custom at domain.com. Let's keep the mobile number as 987 whatever. Custom says I don't want a phone. Push a submit. Awesome. Back here to your storage account. Do a quick refresh. You have got one more entry, right, for custom. That's good. So we can able to store the data. Next, what should we see? I've got my application up and running. I go to my container apps. I can see my container app is healthy, it's good. Now, how do you confirm that Dapper is running inside? It's quite simple. I've got only one revision. But that's a default revision. You can see here the revision and the traffic. Consider that I'm going to create another new revision, right? Based out on this. Say like call it as a V2. You see here, that's my app ID, iContoso, and I've given the Docker source. The tag is my Docker version 2464. If you have forgotten that, it's 2464. This is the image version which I've pulled, right? It's a public image, 2464. Then if you're back here and say like add a new version, you can just quickly go ahead and say that V2. And okay, let me pull out the same. 2464. In your case, you can just do whatever the version you want to, and I just click on add. So this is going to spin up another revision for me. I can just say don't use the previous version, better use the new version. That's how exactly I apply the revision when I have an update. Okay, this is how the deployment will happen. So once this is success, you will see another app running here, right? The revisions here. So you can just quickly go and toggle, put 50% to the different app and 50% to this one. That's really beauty. All right, so you have logs here. You can just explore the logs. Because of the time, I don't want to cover all at once. But because I have to take a different query and then run and show you what is happening in the logs. As I said, it has got a secrets, right? So let me close this notification. You can see the container registry password, which I haven't created in the portal, but I have defined it in my Bicep file. All right, so where is that exactly? Container apps.bicep. Here we go. I said container registry password. So it created the container registry password, it captured it. But the bad part, what I observed is it's not masked. So when I click on this, I can see the password, clear text password. So probably Microsoft will consider that in the future release. Then if I go to my ingress, I should see the settings, whatever I've done. I've done an ingress enabled, visibility is external. Back to my code, ingress enabled, external true, target port 80. Cool. What is the scale? So let me go to my revision management for a quick minute. Boom. So that failed. That's okay. That's not a big deal. So I've got my app here, right? So if you see the Dapper, I've got Dapper enabled because I said enable the Dapper with the app port 80, app ID as iContoso. This is my table storage, state store management. Isn't it that cool? So I've not done so. Okay, yeah, here as well. So when I look into this, I get a storage account key. It has to be masked, but that's okay. That's good. But why my revision failed? What is the reason for that? Let's see. Probably if I explore the log analytics, I can see some information. Let me try to access this application. At times in the portal, I may see it's failing, but it will be functioning. It's still in the preview, right? It's not production ready, so might happen. Not sure. right? So this is how we have explored the Docker apps, and I spent a couple of hours writing up the Bicep code and writing up the PSHTML and the PowerShell code, and built my own small application. I hope that this may help a couple of IT pros across the geography to spend some time, migrate their application, sorry, the PowerShell scripts to Pod application, and build some microservices around it, or build some small web application and make it used for your immediate team members or to others in your organization. I hope that this is pretty useful for IT pros. Thanks a lot. Thanks a lot for your time. All right. If in case you have any questions, you can just follow me in Twitter. You can post it over there, or you can just connect with Kasam, who is the organizer of this event from Dear Azure. I thank Kasam as well as other organizers who helped Kasam. Thanks a lot for hosting me. Fantastic. Have a great weekend ahead.